Live. In 3, 2, 1, you're live. And we're live. And you're live with us today. Hey, how's it going? Hello and welcome to this virtual studio of live streams. The Wednesday show of live streams. We have a very relaxed setting. I have my friend and my colleague here today. As always, my co-host is Sergei. Sergei, say hi. You are live.
Hey,
That's great.
hey.
People, do we have people? Like, do we have an audience? Are you watching this right now? If you are watching this, I see right now not so many people are watching because we didn't come in time, which happens. So let's see if we can share this URL to some of our Twitterverse. Maybe someone will join us.
Maybe.
And we'll see how it goes.
Oh, hey, Artem. Nice to see you again.
Only reason we need to audience to understand if people are hearing us correctly. Folks, if you, I'm just saying something, and Sergey will say something. Sergey, say something, because last time.
I'm saying something.
Saying something. Okay. Hopefully sound is great. Hopefully picture is also great. Hopefully there's no phantom echoes as we usually do, because it's time. It was like what, like episode number 8. Episode number 8. So we have to be good at this one, right?
I think when we enter past 10, then we have no excuse of making technical issues, but we still have a couple of episodes to screw up everything. But I hope that today everything will be fine.
I mean,
hey, Pedro.
It's not about the quantity or quality, right? It's just like every time we're trying something new, like, and I guess it's a contagious, because like every time when we start doing streaming, you bring in, hey, what do you think about this new mic? How do you think I will sound with this one? So that's funny. So let me see. Let's see the comments. Let's see the comments. I forgot that I have a comments here, so let me quickly switch here. So we do have Pedro. Pedro is not the first time, right? So Pedro is our regular, and Artyom says it's loud and clear, which is very nice to hear. Folks, I hope you also see. I hope also see these YouTube comments are also popping up. I think it's good. Technology is working. All right, Sergey, how you been? How is life?
Well, a lot of things have happened. A lot of things are still happening. A lot of distraction around, by the way, because there is at least one topic that probably we won't be covering today, but
U.S. election.
Is talking about
election of U.S. president. We're not going to be talking about so. Even though I promised some people that we'll discuss. No, we're not gonna. So we're not gonna discuss this. It's a stream about tech, right? Should we call it as like a video cast, podcast? Because I feel sometimes we actually want to talk, right? We want to talk. We want not only like show off some of the things, but also want to talk about it, discuss some of the things. That's what I like about the this program, is that it's not only about the tech. We can talk about some news and some of the things in IT that happened.
You know what I wish? I wish more interactions with our viewers, because I know that some of them, like sometimes they share some of the feedback or some of the questions after the stream, and I'm like, why not during the stream? Like sometimes I just want to see them asking the same questions but online, so that we can shape the direction or like change the direction of what we're talking about into something more interesting, maybe, because currently we have to come up with these ideas, and so far I think we've been doing well. But yeah, please feel free to drop your questions. Feel free to challenge us. Feel free to do whatever you want, because we are here and we are live here. We are not recording video, we are live because we want the interactions with you, our viewers. please do.
And I also will try to bring some of the Twitterverse here. Live streams now. And I also will tweet about this. Today was actually my it's my another 4 hours of talking. I was doing the workshop this morning for some of our customers. We're talking about some of the stream processing, naturally. What else? And I want to show something. So couple things that happened for the last couple days, the weeks or whatnot. I did a Halloween party. I did a Halloween party at
oh, nice.
in the live streams on my another channel, in the Confluent channel, where I was impersonate Bruce Springsteen. At least there was an idea, like a spring streams, Bruce Spring streams. You got the idea, right? And I even played on guitar a little bit. So probably we can even jam sometime. You know, we can even jam. You have a bass guitar. I have a solo guitar.
Yes, precisely.
We need to do this one day. Like, let's do this one. Like, if this video hit like a 50 likes, we will jam next time. So we, like, if you really want to hear the Sergei's playing bass and I'm doing some of the solos. I'm not gonna shred. I'm kidding. But yeah, that's check this out. I did a workshop, like 2 hours workshop, when I was like doing the Spring Boot, Kafka streams, all this stuff. It was pretty fun. It was pretty fun to do. So I hope some of you were there, and maybe you also can enjoy. So I see some of the activity in the comments. Let's take a look on this one. So. So
getting quite some amount of questions about
There's
Kafka.
some interesting question. How much should I scale my Kafka brokers to achieve average latency with 500,000 megabyte? That's a very interesting question. Let's break this down, right? So how much scale am my Kafka broker to achieve this? What are you trying to achieve? Are you trying to achieve high throughput? Are you trying to achieve more like reliability? Because there's multiple things that you need to turn in terms of like fixing these knobs and stuff like that. And those things maybe not 100% would be correlated to another. Like, what is your requirement? So in this case, we need more information. Like what's your durability requirements? Like, how long you want to store those messages? Is it going to be like an end-to-end latency from producer to consumer? And what is the like how many messages you have? Like, where are you running this? Are you running this on VM or running this on containers? Where are you doing this? There is a very good tool out of the box. Okay, this says on Kubernetes. Okay, so it's a very good point. The 5. Yeah, start with 5. Start with 5. There's a tool. There's a very good tool called Kafka Console Producer Perf or something like that. I usually start with this to see how things are working and what kind of numbers I have, because those latency numbers are not that big. The less than 50 milliseconds. It's not like a rocket science. It's something that you can achieve with pretty good network and with pretty good. More or less like a beefy machines. On AKS, how much count we need? Okay, so I guess there's some additions.
By the way, sorry for interrupting, but you know what I like about Kafka? And I'm not employed by Confluent and not going to be employed by Confluent. So make no mistake, I'm not talking marketing, but rather user perspective. But what I really liked about Kafka is that back then when I was deciding on whether I should use Kafka or not, I didn't have to do this research on whether my target SLA will be met or not, because I just know that Kafka is fast. And this assumption also helps me when I experiment, because if I see some low throughput or I see some big latencies, then I'm asking the question, why is it low? What did I wrong? It's not like why Kafka is slow. I just know that Kafka is fast. So I'm focusing on my application. And this is nice. It's nice to know that some component of your system is fast. It's the same with Redis, the same with Kafka, the same with other technologies, similar technologies. But yeah, that's the thing I like. It's predictably fast. You just know that it's fast, and then it's a matter of
I will try to find a thread. Colleague of mine, Jacob Korb, he's one of the senior engineers here at Confluent. He's working on the professional services side of things, and he actually wrote very good Twitter thread about like a kind of like a checklist, what need to check before you start like a tuning Kafka for performance. And it also very well correlate with the this the Alexei Shepelyov has this talk when he breaks down like the testing, performance testing, and performance kind of investigation into multiple layers, and that there's a different layers of performance that you can achieve with certain amount of effort, and what kind of numbers you should achieve. This is why there's a green zone, yellow zone, and red zone. And the green zone usually it's like a very easy to achieve by just like paying a little bit more attention about certain things. For example, like if you care about only throughput of the things, you just only care how fast thing will go through, you might not be interested in durability. So that's why you can, disable something like acknowledgement. You just do the fire forget. You just know like you need to just like have a super fast fire hose and don't care about internals. Like you need to have like a fast production. Or like you can change like the number of the batches, or you change like size of the batch and things like that. Like if you want to care not about latency, but like about of messages that you can produce in one shot or things like that. So these things will give you very high benefits very quickly. You will get this the performance gains very quickly, and this is what they consider like a green zone. So this is something that usually some of the knobs that system provides you, so you can play around this do some stuff. Next is the yellow zone, which is gives you also tangible results, but like the ratio of kind of like a speed improvements, it would be like a drastic. It's maybe 100 times less, but the things that you need to apply, certain skills that you need to apply there. So this is where you're going into the world where you start optimizing like some of the your application, also like different knobs in terms of like you're measuring, maybe you're switching to different serialization formats, so you get like a very smaller payload. You start doing this type of stuff. You start looking into different different things inside the system. Probably you even do stuff like having some sort of Java agent and seeing how good your Kafka, say like network threads perform versus how to request threads perform. So you start seeing how good Kafka is handling certain requests, and if there's some of the bottlenecks that you can discover. You not necessarily need to profile this, because all these metrics are available through some of the not even instrumentation. It's available for JMX. You can get all these metrics through like metrics report or things like that. And this is where yellow zone, you definitely will get some benefits. You will definitely get some of the performance improvements, but this is something where you're spending more time. And there is a red zone. Red zone is kind of like when you super like a micro benchmarking and you start investigating, okay, so should I replace I don't know, the socket selector that is kind of default implementation using Java and IO, should I replace it with Netty? Should I go and re-implement this network stack using something different? Because Netty supports some sort of like how it's called, something, EPO.
EPO. I mean, it's EPO, not the cool thing anymore. The cool thing is IOU ring or whatever that's upcoming mode in Netty or in the kernel actually that will just speed or like increase the performance by a magnitude in some cases. So we are yet to discover some performance improvements in the platform. And it's amazing, by the way, that Nati can integrate with this thing, and then you can update your kernel. And then as soon as you have Nati supporting the thing and your kernel supporting this feature, then you, boom, get like plus or like 10x improvement in the performance. That's just amazing. I didn't think that we could achieve that, and we are just doing micro optimizations at the moment because we already discovered a lot of great approaches like asynchronous non-blocking programming, blah blah blah. But apparently we can go even further.
Right, exactly. So, and this type of stuff that maybe would be for you as application developer would be in your like yellow zone, but for developers of the framework, for example, right, to support this type of stuff, it would be a lot of effort, and you will get definitely benefits. But it's also kind of you need to know why you're using this. So I will try to find this. I will try to find this the thread that Jacob started. But Arpit, thank you so much for this question. It's a very good question. That it's not like you get answer, right? I can tell you, okay, so do 10 nodes, but 10 nodes might not necessarily make things faster. If you look into some of the sub-millisecond throughputs, maybe Kafka would not be a good candidate here, right? Because if you want to have an end-to-end latency that less than millisecond, maybe you don't need to even using the disk-bound system like Kafka, like in memory queues or like some some ring buffer, some what's the LMAX the disruptor type of thing, allows you to do this like pass messages very quickly. You might not necessarily need to have like a very big reliability. You don't need to have a disk persistency for this. So I remember when they was talking about the LMAX, they even said that they will deploy these systems in the machines that are really beefy, like they have a lot of memory. They will have their own build of JVM that doesn't have garbage collector. They just like remove the garbage collector by recompiling this JVM. And that will give them every time when they failing with the out of memory exception, they just like restarting this application because application like stateless and it's super fast to rehydrate this with some of the data. So, but this is optimization and really around the red zone. This is some optimization that they know what they're doing this, and that maybe not for everyone.
And since we are talking about optimizations, I guess we should always remember that there is a fourth zone. A very important one is when you have no idea what you're doing, but you're trying to optimize, and then you're entering the brown zone. Yeah. Okay. So yeah, please don't try to optimize things if you have no idea what you're doing, because most of the times the default configuration will be better than wrongly optimized thing.
Yeah, but don't be in the brown zone.
Yes, yeah. But since we're talking about optimizations and performance, I see another question from Artyom about Reactive.
Let me bring this in. So, like, let's start with this one first of all. What are prerequisites of using Kafka similar technology? I mean, what points when you look at the backend services make you think, oh, this is where I should use some kind of queue and messaging service? This is, again, I guess it's also like a brown zone of the optimization, right? Because it doesn't matter if like a Viktor or Sergei told you to use so, like because like they're so cool and they're influential, they were talking about Reactor and talking about Kafka, and you thinking, oh, wow, I really trust these guys and like I really trust their judgment. I probably need to use it everywhere. So this is where I start talking about like probably you need to use your own judgment to understand where are you, need some of this stuff. So essentially, where to use messaging system, Sergey? So where you would say that, okay, so this is the good candidate of using, the message passing, message-driven system like Liklus, for example, for system architecture, right? That's a question. I kind of like a pass this to you.
Yeah, thanks. And you kind of lost me, but I think I'm catching up. But yeah, what I want to say is that every architecture differs, and your experience may differ, your mileage may differ. meaning that I would not recommend to start with event-driven system if you have no idea how event-driven systems work. You may have theoretical knowledge, and now you're joining a startup and you want to apply this knowledge on some real product. That's actually what I did at my previous job at Vivi, and it was like super successful because we implemented a very flexible system. And it's not like I had theoretical knowledge, but I cannot say that I had like 10 startups that made it to exit where we started event-driven. No, it wasn't like that. It was rather like 1.5. But yeah,
one has an exit, another one kind of like, yeah, I had the exit.
yeah. But yeah, like it kind of depends on your knowledge and what you want to do, and if you feel confident or not doing one thing or another. But what I can say is that event-driven system is a flexible system. You can literally shape it the way you want without changing much. You don't have to refactor half of the system. You don't have to split the monolith. You don't have to do many things that are usual for microservices where you have service-to-service communication. You don't even need to think about circuit breakers, load balancers, whether to use REST or gRPC. That's the question you would not be asking yourself if you don't have to communicate between services, if you're just reading something from the events.
Yeah.
But on the other hand, it also depends on how you want to organize this whole thing. You can do shared log infrastructure where you'll always read, where you will always be reading from the same log. You can do kind of message bus with something like RabbitMQ.
Don't do files,
other technology.
Don't do files. Do not like have a one system write to file, another system read to file.
Well, Kafka kinda,
yeah, exactly. You end up implementing Kafka yourself, basically.
Yes, yeah, precisely.
I think this is the main point when Sergei says, like, every time when you're thinking about inter-process communication, you need to think the way how you can these services will communicate, or like these systems will communicate. In my rule of thumb is also like, if you are at least have some knowledge about the load, how much you will be passing through. Start by experimenting. Start by setting up an environment for performance testing. But it not necessarily needs to be like a very thorough, but at least you need to not know the numbers and the baseline. When you don't know baseline for testing, you cannot just demand that, oh, my system needs to perform on certain levels of on certain SLA. I promise this something to yourself, because like if you're architecturally not capable of achieving this number, so what's the point, right? And again, this is where you're starting with the green zone, right? You just do simple things, just like try to see what's the end-to-end latency, something that can be easily seen, and for more or less senior engineers, more or less not a senior, more or less seasoned engineer, you might have some ideas where they have 100 of requests, but you need to spend like a few seconds to solve those, which is something is not right with the modern even hardware. It's not something right, so probably something is not configured correctly. Always start with some baseline, and after that, when you start adding more and more components, for example, adding more services, they need to communicate. So in this case, you will start getting an idea how your baseline latency or baseline like a SLA that you promise to your customers will be changing in the in a regression or progression. So usually when the people say where to use the messaging system in general, it's where you're trying to kind of decouple multiple things. For example, you're trying to prevent that people will be hitting your database directly from web request. Because if you growing into web scale, like thousands of requests per second, directly relate to database connection pool will be also not very wise, right? So you start thinking, okay, so how you would scale this if your application is stateful or your application is stateless. If it's stateful from perspective of like a request response, you can put more instances and load balancer on top of them, and after that, this application will hit database. After that, you start thinking about, okay, how I prevent this application to constantly reading this database where this data would be the same. You're probably introducing some sort of cache in between, right? And we didn't talk about queues at all here, because there's some ways that you can do, some things that you can do even before start introducing the queues, right? Once you start introducing the queues, you need to start forgetting about this like a transactional request where you can trace from a request up to this database, because like it starts communicating through the queue, and you need to find the ways how you have idea how this message will be traversed through the system. It's it's a very good question, Artem. It's great that you ask, because it's very difficult, in my opinion, to talk about something like this in general, right, without bringing particular examples. And I guess it's a little bit of consultant in me talking, because usually when the people asking questions, my first reaction, it depends, right? It depends. Let's talk. Let's what you mean. And with my questions, I'm trying to help customers and users to establish what exactly they want to do, right? And what they mean by, what's the prerequisite to using Kafka.
And you know what else I figured? That if you have an event-driven system, you can always migrate it to the classic approach where you have services accepting requests, storing something in the database, and reading from the database. Because if you make the decision, and that's a cool thing, like when you go event-driven, you tell your CTO that at any moment of time, we can convert it into the traditional approach. And then he's like, okay, yeah, let's go. Like, let's give it a try. But you always have this plan B. But the other way around, when you store things in the database and you have like 10 databases, each database is a source of truth, then you cannot easily migrate to the event-driven system. You could try something like Debezium and similar technologies, but it's going to be quite a migration, and then you need to change many things. And most probably you have some service-to-service dependencies, while in event-driven, you always decouple. So that it's also good for experimenting, because event-driven system is flexible. You can quickly progress with development. You can adopt your product to some changed environments or requirements, because it's a common thing in startups. Damn it! Why I'm saying environments? requirements are being changed like constantly. But going back from traditional or modernizing your architecture from traditional to event-driven is much harder, so that it may not be a good idea to start with traditional and then try event-driven if you're planning. It's easier to start with event-driven and then like, okay, it's just too hard for us. We want the traditional approach, and then you make short migration and boom, you're done. Do you want me to answer some other questions about Reactive, by the way?
Yeah. So let's talk about this one. Let me display this on the screen in a sec. So similar question to Sergei about Reactive, like where should start using, has a lot of expertise in the area, blah, blah, blah. So basically he's praising your experience in the Reactive world, but essentially the main question is the same. Like what's the prerequisite? Like how you know that you're mature enough to start with this one? So I guess that's the kind of takeaway from this question.
The whole thing with Reactive and the efforts around Reactive is to make it easier and to make it friendly to the newcomers. So if you feel that some Reactive library isn't friendly, and sometimes it is the case, like sometimes you have to spend some major measured time just learning the library, this may not be a good indicator. Our effort is to make it easier to use asynchronous non-blocking by utilizing Reactive frameworks. So if we are talking about the levels of expertise, then I would not be afraid of Reactive just because you have, let's say, 2 years of Java experience. It's okay. Like I remember being approached by some junior engineers, let's say last year at Spring One platform where we met each other, by the way. It was cool.
It feels like 1,000 years ago, right?
Yeah. It's been like, it's actually been a year, I think, or a bit less than a year, but yeah, Jesus. So yeah. So I got approached by a junior developer, and he was very shy. He was afraid of asking questions, but I figured that he was using Reactor and web plugs at a very decent level. Like questions he was asking were the good ones, like some advanced questions from a junior developer about Reactive. Like sometimes you talk to senior architects, and they ask you some questions like, I don't know, why publisher has to be lazy? Like, why can't we just keep the publisher, one publisher, one consumer? Why we should overcomplicate? And such questions, like you understand that these people, they do not understand the power of Reactive. They do not understand the reasoning why certain things were made so. Like it is lazy so that we can resubscribe, so that we can do retries, we can do timeouts, we can do repeats, we can build the pipeline before executing it. And when you have even entry-level experience with Reactive, you start getting it kind of. But another question that people usually ask is when is a good point, like performance point or like performance level of your service, when should you start using Reactive? And that's a common misconception that I don't like, that Reactive should be used for performance or like heavy performance or Jesus, high performance
systems. Yep.
Yeah, like I would also use Reactive for some small services with 10 requests per minute, just because I control the resiliency of the service. I don't need to bring other libraries like Hystrix and others. I have everything I need. And for me, like it's personal opinion, but I find it easier to read Reactive code just because I see what's going on. I see how things transition or how things flow from one IO source to another IO thing, be it, let's say, from Kafka to some Cassandra database or from Cassandra to the web layer. It's just easier to follow when you
and
understand.
I agree in same thing. It might be kind of like confirmational bias, when you know system very well, so you can tend to use this system very often, and it's I don't know where's the causality or correlation. Where's the chicken, where's the egg? How you start this. I remember, like when I was in Hazelcast, I can write pretty much every application using the Hazelcast and like solving all use cases using Hazelcast. And I don't need to have like traditional database, for example, if I want to store this in the cache, so I can, I don't know, using this like hot restart feature that prevents from losing the data, or like it prevents me to restarting this application. Same thing with Kafka. Maybe there's some of the components of Kafka that I can use for inter-process communication, where I would maybe end up with using some queues, right? So far and so on. So it's it's use what you know, and basically like see like how you be efficient with this type of tools, right?
But never stop learning, because if you use what you know without learning new things on pet projects, on experimental projects, or just pushing some ideas at your jobs, then you'll be you'll start getting kind of like not outdated.
Obsolete.
Like your knowledge becomes
obsolete. Yes,
obsolete.
the computers will replace you.
Oh yeah.
So Roman is asking, can reactive cloud streams adapter be considered as really reactive, because it does request.long polling? I can answer it because it doesn't use Reactor Kafka. It uses Spring Kafka, which is an adapter on top of producer and consumer, which is not reactive. So there's no like reactive thingy, in my opinion, there. So or back pressure achieved with downstream operation like a flat map. Yeah, I don't think the Spring Cloud Stream it is reactive. Like if you're talking about like using reactive frameworks, if you're asking about this.
I think it's important to understand when library supports reactive API and when library is reactive, because one thing is just accepting Flux and Mono or publisher as a signature of some function, and another thing is being reactive under the hood. So in the current state, Spring Cloud Stream, last time I checked, it was reactive friendly, or it was supporting reactive APIs, so that if you want to run your processing with reactive pipeline, you do that, but it doesn't mean that underlying technology itself is reactive. They do use Spring Kafka, and Spring Kafka uses Kafka client like in blocking old way. So do not expect that you change your function from void do something to mono void do something, and you become reactive all the way down. But it's still a great improvement, because when you know that you can avoid blocking, when you know that you can do some pipeline operations instead of just one by one, then you should do it, because it will improve your system. And eventually, I'm pretty sure they will reach the point where the underlying implementation is also reactive, because it's just better, especially in the libraries where you can do it once and then everyone will benefit. But it takes time. And the opposite is Spring Web Flux. In Spring Web Flux, everything is reactive. It is the reactive library for Spring. And when you run processing through Web Flux, then the HTTP part will also be reactive, meaning that there will be reactor native talking to native, everything will be asynchronous non-blocking, back pressure supported, and so on and so forth. But yeah, it takes time, and Spring did it, Spring Framework did it, I mean, Spring Web did it, but Spring Cloud Stream is catching up, because there are also other great features being developed there for the customers who were using the library before this reactive hype, which is totally fine, I would say.
One more question about event-driven systems. What would be top 3 difficulties, I guess, when implementing them? I guess one would be versioning, but interesting to hear your thoughts.
Oh, that's a nice one. Do you mind if I start?
Yes, please. Absolutely. Because yeah.
There are challenges, of course. It's not a silver bullet. And actually, some of the challenges are not that easy to solve unless you decide that you don't need to solve them. You need to have something different. So, for example, eventual consistency of such system can be a challenge. Like with event-driven system, you think HTTP status 200 versus 202, like OK versus accepted. So with event-driven system, you will be returning accepted, because you don't need to wait for the event to be processed before you return to the sender. You just say, OK, I accepted this event, and that's the most important part. It's important to accept the event. It's important to put it into the system, and then the processing will eventually process this event. So one option to solve eventual consistency is to you always get something back from publishing, some offset or something else. So for example, what we did in our test, because it's especially important in tests, you don't want to retry some read operation until you see the result. You just want to check that, okay, it got processed, and now the state represents this. So what we did is, so 2 options. One option is to read the offset that you submit, and then you wait for this offset to be processed by reading the acknowledgements. Or another option, which is a bit more trickier, but fun one, you publish a fake event into the event log, and then you wait for this after you publish the original one. And then you wait for this fake event to be processed, and now you know that everything up to this fake event got processed. So that if you publish 10 events, you don't need to wait for each event, but rather you publish after that event.
It's like a tombstone, but like application injected tombstone to.
Yes.
And it's common pattern, as a matter of fact. This is not something that would be feels that artificial or something like that.
Oh, definitely. It's just you have to change your mind how you test event-driven systems. It's the same with asynchronous systems. With asynchronous systems, when you test them, you no longer just do A, B, C. You do await A, await B, await C, and then you assert the result. Remember last episode or episode before the last one, we were checking your test and we figured that one of the tests was running assertions asynchronously, and they were not executed in the same thread as the test. So the test was releasing the thread, but then assertions were failing in the background, but the test was passing. It was marked as pass test. It's similar thing here. Just when you learn how to test these systems, it's not a big difference compared to classic or traditional approach, but something new to learn. On the other hand, it also sometimes just when you test, it's closer to how it will be in reality compared to approaches where you modify some internal state, for example, with mocking or something else.
I think there's another very good question for you. Can you just give me a second? I will show this on the screen. Can you provide examples of reactive libraries that you think are too complex to use and understand?
Nope, because I'm a good guy.
I think the answer
it can
here
also be a personal opinion.
No, I mean, like, I think the cool thing about the modern approach to all these kind of libraries, it's my take actually, is the people actually paying much attention about documentation, about API examples, because they understand without that library won't survive. So why would you use library that's complicated or difficult to use to understand, the different require, where there's a plenty of libraries that good to use and quite easy to understand and things like that, right? So I think this modern open source, successful modern open source projects have to have this, good documentation, good examples explaining, maybe even some of the, evangelism behind, like someone is doing videos explaining this, or like talking to other people, or like helping people in a I don't know, in a Slack or some Telegram channels. So I feel that's why kind of reactive is getting traction right now, because smart people develop it, and also they smart people not because they, smarter than anyone. They're smart because they know how to make complex things usable and how to use these complex things, is my opinion. So this is why, like, the reactor, the vertex, some other like tons of the frameworks, they have a like relatively good documentation, so you can quite easy to understand. And did we I think one of the live streams we actually broke down some of the popular libraries that are available there, and we talk about some interesting frameworks that are available. We did the live stream that where we touched on this one. It was a very good one.
Yeah. And by the way, the only recommendation I can give is nowadays most of reactive frameworks, they're already fast, so performance is not a question. They may vary by 5%. Like this library is 5% faster, but does it really matter as much as developer experience? I would say no, because if library has an ugly developer experience, then it doesn't matter whether the performance is great or not. Just you not be as productive with some other library as you could. So when you look at any library, actually, it's not just about reactive libraries, but any library, I would recommend to check the developer experience story, whether there are tools provided for the developers, whether the library thinks about the developers or just about the target JVM that runs your code and it runs it fast. Because just so that it doesn't look like I'm praising a reactor, for example, just Kotlin coroutines, they did a lot of progress last year with developer experience, and you'll get some neat features like block count integration. Then they just announced the next release of Kafka. Why I'm saying Kafka?
Because Kafka is
Kotlin
awesome.
coroutines. Yeah, KK. So yeah, they released Kotlin coroutines with block count support with I think it was released last year, but stack traces that include some tracing information, some context support. I think Kotlin coroutines is the only library that properly integrates with Reactor's context.
Wow, that's pretty cool.
And I didn't know, like they just spend major effort integrating with the context so that if you mix both, you would not be losing stuff. You just use them and they interrupt with each other. They're not messing with each other. So just pay attention to these small details like developer experience, because for me, that would be the most important. And performance can always be improved, but also nowadays, most of reactive libraries, they come with great performance automatically because the patterns are the same.
What else?
By the way, Roman Lebedev is commenting that he discovered an unexpectedly nice usage of Reactor for simple code using direct processor field inside the service and exposing it as a publisher of logged in events. Yeah, and actually, we just reworked processors in Reactor 3.4. So now it's less confusing to use them. We code this new abstraction, we code things. It's around these things, not the processors now. Have a look, because I know that processes were a little bit confusing to use, and they were focused on wrong thing. So we spent a major effort rethinking how such abstraction should be exposed to the users. And we figured a very nice abstraction that is very easy to use, but also very convenient to use. You just understand what's going on. So Roman, if you're using direct processor, do have a look at things, because I think you'll appreciate this new API. And I agree that things like processors, they help bridge old blocking world with new reactive world, so that when you have some source that is blocking, and then you need to push data somewhere, processors can be a nice choice. There are other options. Some of them are implemented on top of processors, but sometimes just the processor would be a nice place to start using reactive from some non-reactive code.
I'm trying to look. I'm trying to look this the performance library that can performance thread that my colleague shared. So yeah. Thanks for these questions. We continue. Let's keep them coming. As you can see, we can just like talk about this type of stuff, and it feels like expert zone every time when you do like a conference, and like you're done with your presentation. After that, you can talk about stuff, and you're talking about things that like you care about, and this kind of stuff. That's
the most interesting part. Like, why would you attend conference for the talk, right? Like,
right.
You can watch it later, but talking to the speakers and just exchanging ideas, and even talking with other attendees, because sometimes an attendee can tell you more than the speaker.
Yeah.
It really happened to me many times. Also with me being a speaker, by the way. So yeah, I think that's nice when conferences do that, like post talk. And with online conferences, for me it was a problem, because some of the online conferences who started in March and April, like you watch the talk and then talk ends and you continue to the next talk. So you're not getting this experience of talking to the speaker and other attendees. But now I see conferences doing this thing where you just finish your talk, and then there's a room where you can talk about things and discuss some ideas and ask more questions. And some of the questions that others may be asking could also be helpful for you to think about.
Yeah, exactly. That's how I personally like to get the the content for the next talk, where learning something from someone, and after that turning into something useful, like some of the materials that is really useful for some of the things that you can do.
Mm-hmm.
All right, so let's see what else. Is there any ways to start doing reactive programming with TDD? Sergey, are you a fan of TDD?
Of course, of ITDD, like integration test driven development. Obviously with test containers, but yeah, if you have integration tests, then you don't care whether your service is reactive or not. You can write your test with blocking, all like web template or whatever, using REST assured, of course, and other libraries, while keeping your service fast and reactive and stuff like this. So that it shouldn't really matter whether you're doing TDD or whether you're doing TDD with blocking service or with reactive service, as long as it is an integration test. If you start with unit tests and you do TDDs, then you're kind of wasting your time actually. But with integration testing, you don't have to rewrite the test every 5 minutes when you change the signature of your method, meaning that you can easily do TDD with reactive services.
Right. Yeah, that's makes total sense. So let's bring something to the table as well. Like it's people asking some of the things. Let's see if we have something. You want to share your screen because you have this the tweet of the week session of this TV show.
Let's do that.
Let me know when you're ready. I will switch to your screen then.
By the way, nobody have commented about the idea of doing this tweets of the week, meaning that we will continue doing that unless you say, "Hey guys, please stop." Okay?
I think it was a great idea. I think it's brings us closer to like a podcast rather than a live stream. Yeah. But hey, that's still awesome.
And we got some nice topics to discuss as well. And today's Twitter digest, I would like to start with.
And you're not showing anything. You're showing your browser.
I am. Can you double check that you're sharing my screen? And I can also check that I'm sharing the thing, but I'm pretty sure I am. Yeah, you should see. You didn't. So are we doing it or not?
Yeah, give me just 1 second.
Oh yeah, sure. Yay, technical difficulties.
So we're looking at the using test container for integration testing, right?
No.
Because this is what I see on your screen.
Oh, really? Yeah. Because I even checked OBS Ninja, and I think I'm sharing Josh Bloch's tweet. But I can triple check. Actually, can you just make it live and then I check, because I'm not seeing my screen. I still see our faces and we are looking as crazy guys.
Yeah.
What's going on? But yeah, meanwhile.
Yeah. So right now, just like open OBS Ninja shows your test containers browser.
Maybe,
yeah.
Right.
Maybe your screen is in a full screen mode, and after that, it prevents you to show something else.
Then can you unshare it for a second, and so I make sure that.
Absolutely. Yep. All right. So meanwhile, I will entertain you. Oh.
Yes, please. Worst case.
Let me actually show something. I did the workshop today. So I did the workshop today, similar to the workshop that I did with these the Bruce Spring streams and things like that. And some of the things that I forgot to show people during this the Spring String workshop is something that I really used today. I just like went full blown like no slides type of thing today. So I was trying to also showing by like telling by showing, instead of kind of like showing your slides and showing some of the oops, state doesn't match. What is what? Live streams, everything happened Everything happens, all events occur in real time. Let me try to see if login will work, because something is changed. Hopefully. And we golden. So how would it's always like it's always very not what word I'm looking for. It's not difficult and it's not challenging, but it's always kind of like I feel awkward when we're talking about distributed system without like actually showing this. And for a very long time, in order to show you partitions and how producer and consumer reading this, I need to either using slides because there was no good way to visualize it. And I found that we do have this thing called a data flow. Data flow, which says no active topics. It can be because I do have some application that produce some data. Let's see. Let me see if it's also will work. Hide inactive topics. So there is a data flow that allows me to shows what is going on there. I have a multiple topics here inside my application. It's a few application actually work with those topics. Let me display in 10-minute snapshot. Let me refresh it. Maybe it's my come on. At the moment when I wanted to show some of the cool beats, I'm getting this error. Let's see, 98 if it works. Submit. So it went. The process it here. Okay, good. Am I on the right Kafka cluster? Am I
on? Says that it displays 10 minutes snapshot. So maybe it's just not there yet.
It's supposed to be. Yeah. That's that took some time. So let's show some of the inactive topics as well. So there is a data flow UI that allows me to show like some of the topics and how the application will be tied to these topics. Say I do have an application that essentially writes data into a transactional request topic, and my application will produce this. But for some reason, it doesn't show me this. It should, but maybe my something with life. I can show you like how many partitions and how many messages I do have in this partition unconsumed, so I can see this kind of stuff. And it's very difficult to kind of like when I'm talking this and show this on the slide, I can have squares that jumping around, but here's like live system, and I was able to show this on the live system. So the another thing is to see is the different metrics in terms of like what is going on there, what is when the messages were produced and where messages were consumed, and bytes in, bytes out, this type of stuff. And especially it's cool when you need to show something when they interact between multiple different systems. So in this particular case, I guess my computer just like running very slow because I'm running this the stream and plus running some apps and obviously Docker somewhere running always. So this is the topic that KSQLDB uses. For example, there's a KSQLDB app. I can look here and I can see that's stream that produces from the KSQLDB. I see the topic that would be written. I see some of the transaction success topic that was a producer that writes data there. And this producer also coming from KSQLDB. So this is, oh no, I'm sorry. This is actually coming from the Kafka streams because this producer, transaction processor, it's a Kafka streams application. I don't know, like just like I found this like a very funny thing to use, especially for demonstrating what these applications are doing and things like that. For example, there's like a changelog topic that only Kafka Streams application produces because it's how the like fault tolerance and the state replication works in Kafka streams, and we're using this like changelog topic, and that would be produced by a special producer on streams thread. So yeah, that was cool. I'm still. Shall
Viktor,
we try to? Yeah.
there is a great question in chat. Is this UI free, or do we need to pay something to Confluent for it? And I also wanted to add, if I add Confluent platform, let's say if I install Confluent platform on Kubernetes cluster, we also see this nice stuff, or it's
So
only available in
this
Confluent Cloud?
this is in Confluent Cloud only. How you can use it? You either hit me up. I can give you a coupon so you can play around with this. But it's a cloud based platform. So if you're using this for production, it definitely helps you to get yourself around. We're working to actually make this work on. In Control Center. So we're working on this like a data flow UI, so it will be available in your Kubernetes cluster when you deploy. Speaking of which, I actually started building some pretty cool demo for KubeCon. We will be showing, Sergey, you will be super pleased with new experience of Confluent Operator, because I remember you mentioned last time you saying, okay, so I was trying to deploy the Kafka cluster and it says, okay, install Helm, and I was like, okay, fuck it, I'm out. So we are actually changed a lot of new kind of experience. Let me try to open this OBS Ninja again. And now to deploy Kafka cluster, you just need to say create this resource called kind Kafka, how many nodes.
Oh, nice.
And that's it. So you will be able to just like quickly to do this. High video bitrate. Okay, I will try to.
Actually, do you remember Mesos, like Apache Mesos? When Kubernetes was getting popularity, yeah, Mesos was already a thing. And I remember there were some debates like whether Mesos approach is good or not, because they were using the concept of frameworks. Like whenever you want to deploy something to Mesos, you deploy a framework, and then in this framework you create resources. And I remember Kubernetes community kind of attacking them on this approach, like, no, it won't scale well, you need to create a lot of things, it doesn't work well, like it requires a lot of complexity in your system. And later
and now
Kubernetes came up with this shiny idea of operators.
Yeah,
like definitely not the same thing, but it's a new idea where you deploy a framework to your cluster and then you create resources provided by this framework. But jokes aside, or snarks aside, I think it's great that Kubernetes finally realized that this idea is great, and this reconciliation loop is a great idea, because now, like, I tried to deploy some things that were using Helm, like I actually ended up trying Helm, but every time I did that, I was like, why should I do it? Like, what's wrong with Kubernetes if I have to render some massive templates and then deploy them to my cluster? Why can't I just deploy a 5-liner with what I need to get? And I'm really happy to hear that you ended up implementing an operator instead of just providing Helm templates.
So I think here's the small misconception here about the operator. So operator already was doing this. Helm was done there just to like simplify deployment, but like amount of things that you need to lift to get there, it's just not fun. There's too many things, and the Kafka custom resource was too verbose. You need to put a lot of like things there. Now we drastically simplified the process of handling this stuff, and Helm was there just like for templating, and it's a modern DevOps. You cannot do anything without YAML. So so stay tuned. I was working on this demo. It's pretty nice. Probably I can even bring this in one of the live streams in the future. So let's take a look on your screen. So I finally managed to. Can you scroll up and down so we can make sure that this is live? Yeah, that's live. Okay, cool.
Okay, perfect.
So we see in this
So,
the tweet of the week.
Yeah. Tweets.
Tweets.
It's just subset, of course, and some of the highlights. But yeah, I wanted to start with this tweet from David about the current. Like, it's not integrated yet, but it's already in pull request stage and was probably going to be integrated. But that's a method called toList on an instance of stream, so that remember every time you had to convert some stream into like Java stream into a list, you had to do this dot collect, collectors dot toList, blah blah blah. And now we can do I don't know, my list dot stream dot map dot filter dot toList. Very convenient. But what I want, like, okay, that's nice. There are some ongoing discussions on whether it should be a shortcut to list or to unmodifiable list. It's actually very fun to read. Guess we'll include the link into the show notes. But what I wanted to talk about is that I'm one of the folks who are pushing the idea of pipe operator extension methods, whatever you call it, to Java language. Because, okay, they add to list. And we all know that the very next thing that will happen is someone asking for toSet. It will be integrated in Java 18, and then someone will be asking for toMap in Java 19, right? So we'll be adding this, like, it almost sounds like, this, like, you send us $2 million, otherwise we will be sending you one finger at a time. So it's kind of the same. Like, they're just adding these methods one by one, while what we actually need, we need to solve the problem of this class being like already overloaded with a lot of things. Like there are a lot of methods already, and we want to be able to extend it without extending the class itself. That's why I think that would be nice if we could just write some static method that accepts stream, and then we can call this static method with something like, I don't know, my stream : toList, and boom, this method is defined outside of stream.java, while we keep our code sane, and it's similar to extension methods in Kafka, in Groovy, and other languages. Some implicit stuff in Scala, of course, because everything is implicit in Scala. But I really wish we had something like this in Java.
And we don't. There was like, for some reason there was a, maybe it's in my Twitter feed, someone actually was asking about this, like the extension methods in Java. It's like, for the record, I think it's a great idea, but like, yeah, we still don't have it. And is it considered as a syntax sugar? And syntax sugar is not something that Brian Getz and team have invited to implement.
Yeah. Well, I tried to ask Brian on what he thinks about this idea, and he told me that I need to spend another 100 or 2 hours thinking about it before we can continue the conversation. So I kind of got a feeling that he doesn't want to talk about it, and he also assumes that like the current state of mind on this feature is final. While we still struggle with our code, we still have this issue. And yes, they can continue adding these methods to the Java SDK, but it doesn't solve the problem. It only delays the moment where we need some other method on the stream, up to the point where they would not be willing to add the method at all, because they think that it should not be there. Which is a bit sad, but on the other hand, maybe that's what made Java so popular and so stable. Like, lack of features sometimes is better than
too many features.
Scala. Yes.
Yeah. Or like Scala. But like for the all the seriousness, it looks like there's a Scala 3 is happening like really time soon, like really soon, and People just like super psyched about this. And like this time it would be not the Kotlin stealing ideas from Scala. It's Scala stealing ideas from Kotlin.
Which is great. It's better than just not doing something because some other language did that. I think that's
was a mentality.
harmful.
It was mentality of the Scala as long as I remember.
But
Scala
it's nice
guys
to
will come
see
to
them
us and
changing
saying you are
their
not right. Yeah.
Yeah. But on the other hand, with all this .t thing, like .t was kind of a rethinking of Scala in a way. And I'm lacking some Scala knowledge, but I've been talking to some smart Scala developers who told me about .t. And actually, I'm impressed. I'm impressed that they accepted .t as Scala 3 because that's a major change. And yeah, I see some discussions. I see, Scala folks simplifying the syntax and removing some ASCII art-based syntax and replacing with something sane. I think this is great. It may actually give Scala a second reincarnation. I'm not saying that it's dead, but just more new users, more new projects won't hurt. Definitely won't hurt.
Yeah, that's super cool. All right. What's the next tweet?
Oh, the next one is my favorite, actually. It was eye-opening tweet by someone from Oracle. Not just someone, okay. I'm just saying someone because I don't want to, be overexcited about it. But product manager at Oracle said that Oracle is damn serious about long-term support for R2DBC, not just a stopgap awaiting virtual threads, aka Loom. I think that's great news because it means that the whole idea of R2DBC, and for those who don't know, R2DBC is effort that was started by Pivotal of standardizing reactive APIs for databases, for SQL databases. Basically, reactive alternative to JDBC is getting its popularity, and not just popularity, but also getting its adoption. Now we have Postgres driver living in Postgres repo. We have MariaDB driver developed by MariaDB folks. And now Oracle also committed officially, publicly, which is also unusual for Oracle, right? Doing some commitments for some projects. But they just say that, yes, R2DBC is something they are working on and they're committing to it. I think that's great. It just proves that R2DBC is a specification, not just single vendor effort. It no longer is. It never was, but no longer is for sure.
So yeah, that's interesting because what about this thing called GDB? I forgot the name of the spec.
ADBC?
Yeah, synchronous GDBC or something like that, right? I remember what happened with it? Is it still a thing or?
They they stopped working on it in favor of R2DBC and Loom. You can find mailing list where they officially say that, but yeah, it was a major investment, I would say, but eventually they agreed that it makes no sense to develop ADBC because for those who want to be reactive, there is R2DBC. For those who want to be asynchronous and non-blocking, or rather, for those who want to be non-blocking, there is GDBC with Project Loom. Project Loom, it's gonna take quite some time before we see Project Loom widely adopted because you need to update your Java to version 17, and it sounds crazy,
which,
right?
I was doing the workshop today, and we were trying to even though I this is always how it happens. I said we're gonna be using Java 11, and since we're doing the workshop in the a heavily protected enterprise environment, they still using Java 8. So Java 8 is new Java 6, as far as I can tell. And speaking about which, if you folks did not register for Java Love Conference, you will not be able to participate in panel on Java versions.
Oh, it's Baruch.
Yeah, and
Oh, that
apparently
would be
he was
amazing.
able to recruit Alexei Shepelyov as one of the panelists
Right.
for this panel. So, folks, go check this out. Java Love, free conference about Java with awesome speakers, and the Sergei in program committee, and hopefully Viktor Gamov as a speaker.
We will see.
Yeah,
I mean, we have to review everyone equally, right?
yeah, I know. So yeah,
But I'm just kidding. You're a great speaker, so I'm
go
pretty
in,
sure something would
go
happen.
into the next one. So
Mm-hmm. Yeah, it's by Graham. Just it's complement to the previous tweet because Micronaut apparently they released. I think it's preview, but still it's nice to see a module for Micronaut that adds R2DBC support. What actually triggered my attention is that they use. Yes, as part of this project, there is an experimental RX Java client which you can add with the following dependency, meaning that they were able to implement R2DBC client without Project Reactor, but with RX Java. And I know that some people think that R2DBC is a technology on top of Project Reactor. It is not. Actually, in the specification, you will not find anything about Reactor. It's just reactive streams. So we can implement your driver, you can implement your client with any
really,
technology you want. Yeah. And in fact, R2DBC soon will no longer be an independent spec, but there are some ongoing conversations of contributing R2DBC specification to the Reactive Foundation, where it belongs, I would say. And it will mean that it will be controlled by the biggest players in the reactive space, such as Lightband, VMware, hopefully IBM, and other companies. Like I think that's great. I mean, it's just that's why specification was created in the first place, and this is nice to see it being transitioning towards the place where it belongs.
right? Yes, exactly.
The next one is Maven Daemon. Have you tried it?
Yes, Maven Daemon. No, I was talking about the wrapper. Okay, what is that? This
Okay.
is like a similar to Gradle Daemon.
Yeah, I think so because I haven't. I don't have Maven projects to try.
I don't have
But
many Maven projects, to be frank, these days, so I don't know.
I'm thinking about getting more Maven-based projects because sometimes I just want something simple. Like I'm getting older and I want something that I can run in 2 years and then it will be working and I don't have to update my build system just so that I can build my project. And yeah, what caused my attention is that when it got released, I've seen a lot of folks just praising Maven Daemon and how they improved their builds, how they improved their tests. Like I know that some Spring Cloud team members tried Maven Daemon and they it was successful. They got impressive results. Like you can literally cut the execution time just by using Maven D instead of Maven, meaning that
Huh?
it seems to
Really?
be a great attempt. Yeah, and I'm glad to see Maven catching up with Gradle in this space. I'm not saying that Maven is behind Gradle. I'm just saying that in the area of daemon-based
Come on,
build systems.
the Maven is very behind of Gradle, like very behind.
But not in every direction. I disagree.
Name one. I don't know, like I don't know. It's good that there's some initiatives when the people are catching up or like implementing similar features to Maven. But like, name one of the things that Maven did for the last couple years that is like a really innovative in the build space world or whatever. I don't know.
The
Maybe
thing is,
I sound too harsh or too snarky, but and like I sound like a Gradle fanboy, even though sometimes I want to like tear my
okay,
hair
okay,
out
I
of my
have an
head.
answer.
Okay.
So short answer is just one feature. If you want me to tell you one feature, is inline or like not inline, but calling plugins from command line. Like I don't need to add plugin to my build file so that I can call it. I can just do something like maven takipi wrapper colon wrapper, and then it will download the plugin.
Okay.
It will execute it, and I don't have to read the docs on how to add this plugin to my build.gradle file, because with Gradle you obviously need to add it to the build file.
Yeah.
But I want like credits where it's due. I get this argument from Anders Almirai. Let me. Oh, Jesus.
Andres.
Yeah, I'm not sure why and wasn't after that, but yeah, Andres Almirai. He is currently developing core damp. I think that's how it's called. But yeah, you can easily find he tweets a lot about it. But that's a set of plugins for Gradle. That's actually a system on top of Gradle, not just a set of plugins, but that's a system on top of Gradle that helps you doing things similar to Maven. Because apparently, when you work with Gradle, sometimes you miss some of the features that you can get with Gradle. And let me, like, I really hope that I can find this tweet, but I know that he been doing something like a report plugin for Gradle, where you execute your build, and then you see a short report with colors. Perfect. Yes, it's here. Nice. Okay, I think I will just keep it like this. So as you can see, it tells you how much time it took to configure a module, how much time it took to execute the module, and you see this beautiful report with colors, pretty much like
nice.
Maven does. Yes,
Like
but by default,
what's the Reactor Maven, or what's the name of this plugin?
It's
in the Maven.
In Maven, I think it's just part of Maven Reactor.
Yeah.
Their
naming is hard.
Yeah.
Naming is hard.
Yeah. On the other hand, I think Maven was first to name it Reactor, and then Project Reactor came out. So yeah, if we talk about who was first, I think Maven was first.
Yeah.
Yeah. And speaking of Reactor, because RSocket is one of the technologies we are talking about over and over in this stream. But just wanted to say that RSocket, they released version 1.1.0, and it's actually a major release, I would say, because what they did is they looked at their code, and like Oleg the Kuka, he is one of Project Reactor contributors. He loves Project Reactor. But on the other hand, he understands that when you have a specific use case, you can optimize your code to this specific use case. And that's what they did. They just dropped some of the Reactor operator usages, and they replaced it with custom operators. And Oleg knows how to write operators because he is contributing them to Project Reactor, meaning that you get the best of two worlds. You get a super optimized library, and I want to repeat it, and I think I should repeat it like every episode, but please don't try to write your own operator. Don't try to write your own publisher. It's extremely hard, and this is why we have frameworks doing this for you. And in this case, RSocket did that, and they rewrote their operators with just plain Java, plain Reactive Stream spec, and they achieved in some scenarios they achieved like 10 times better performance. Impressive, right?
Yeah, that's
not because
cool.
Reactor is slow, but because you can cut some unneeded branches, because you can optimize for this use case. And it doesn't mean that, or like I already said it, but yeah, just it's a good example.
That's brings us to the point of green zone of the optimization.
Yes, yeah. So it's actually not green zone. In this case, it's more really like red zone.
No, I think it's still yellow, yellowish.
It's the red zone. I just know what he did, and it is the red zone because it was quite hardcore.
I'm fine, as long as it's not brown. So let's
yes, and yeah, rest assured, it's definitely not brown. And other things like speaking of developer experience, right? Remember, and I think even we tried our socket, we had to, kind of do some things that we did not expect that we had to do. Like when you create our socket client, you have to block. Then you also have to handle retrying yourself, or not retrying, but reconnecting. Yeah, they're listening and they added
So
our socket client.
since we're talking about RSocket, I have a question to you. I think this is where I
Mhm.
can use this opportunity as a co-host to to drive this conversation into something that I would be interested in doing. So what about? I have a task. I have a task in mind, not the task in mind, but like I have idea in mind where I would use something like high performance and especially like 10 times better performance than before
Mm-hmm.
in implementing something that I want to show to my viewers on in another channel where I'm talking about the Kafka streams and things like that. I want to implement a kind of like a custom RPC in order to implement interactive queries for my application. So what's interactive queries? It's ability to turn my Kafka streams application into distributed database. And the good thing is that these capabilities are available. So the framework itself provides a kind of metadata. So I can use this metadata in order to discover which node holds which data. However, the framework is not opinionated. So that's why there's no transport. And I was thinking, okay, I would like to implement something cool like this. And like what it takes to implement this with the frameworks like RSocket. So and especially like we can do this in a live stream since you're already sharing your screen and my computer misbehaving in my since I'm running this streaming part, so I'm waiting until my keyboard will be unfroze. What do you think about this? We can add a little bit live coding, live streaming into.
Actually, you know what? I have an idea because I think we won't have enough time just to do a live session. I mean, it doesn't take much, but I think we are already at how like one and a
Yeah,
half
yeah.
hour of doing streaming. So I suggest we're doing this. And thanks for letting me promote something. But remember, I've been mentioning that I was working on an episode of
Yes,
video for YouTube. So
yes.
today, actually, minutes before our stream, and it's partially the reason why we started later, I released the video finally on YouTube. You'll find the link after the stream, where I have a demo of test containers with rootless Docker, just some spoilers, so that you can check it. And yeah, it's some really cool stuff, like some really hot stuff just out of the press. Um, so I suggest we do this. Since we were talking today, like 1.5 an hour of talking, we redirect people to the demo so that they get some experience of seeing, something going on. And we do RSocket RPC and K-streams and interactive query next week, or week after next week if we skip next week, but I think we will do next week.
Yeah, the next week I will probably I will be building something already. So how I started this in order to show these capabilities in my application. So I decide. So first of all, I will show people how they can deploy to somewhere that allows me to scale this very quickly and effortlessly, aka Kubernetes. The thing that we pretty much started to do last time. Remember, we started looking at the scaffold. So I essentially pushed this a little bit further. So I implemented this deployment of Spring Boot application and externalizing config that will be connected to Confluent Cloud through the some environment variables like secrets and things like that. And this I really started liking this scaffold thing. It just like makes this, a lot of things for me simpler, so I don't need to do this like a kube apply and after that kube delete, kube control apply, kube apply delete, and this kind of stuff. Scaffold can do this for me, and I just like I feel, oh wow, I'm super lazy and I love this so much, and this is just incredible. So yeah, that's something that I already starting to do. So that's why the next step is to actually implement this RPC style thing into my application. So I'm
Okay. Since you're doing your, side activity I don't want to talk about because I'm still thinking that, our thing is, the most important for you, and just any other stream you're doing is just some, just spending your time, you do gRPC, and we migrate gRPC to RSocket RPC in our stream.
I was thinking to start doing this like RSocket out of the box, so I not necessarily need to use like gRPC, so I don't need to even do like a gRPC for that matter. So I
But why
want,
not?
yeah. So is it something that available out of the box in the Spring? It's integrated in Spring somehow.
There is a starter for gRPC that more or less helps you to integrate gRPC. But I think that would be a great idea because we can show how we can migrate from gRPC to RSocket. We will also explore what's supported or not supported in Spring for RSocket because it's still ongoing effort, an ongoing investment. So yeah, I suggest that I think it will be a great start where you have gRPC, something everyone knows, or
at least
most
someone
of
knows.
developers. Yeah,
How
if someone knows.
How about like migrating REST?
Yeah, why not?
Yeah.
The cool thing with gRPC is that we can reuse some of the components.
Yeah, like a definition,
spoilers,
definition of the schema.
Here comes spoilers.
Okay, here comes spoilers. Okay. All right, so let's do this then. So, so people, stick around for the show. Again, we continue to do this one. It's kind of not for, to be, closer to people and getting some communication and also do some cool stuff. Let us know about something that you want us to discuss. Also, maybe you just like drop some of the comments into this YouTube comment. Thank you so much, Sergei, for joining me and joining me every week and trying to do this one. I welcome you to Life of YouTuber, since you already published your first YouTube video. That's gonna be awesome. And I really like the style. It's really live, and it's really it's pretty fun to watch. Essentially,
Thanks.
Thanks for our regulars who joining us today, and I think that we will conclude our today's stream. Sorry, folks, for not super lots of like live coding, but like I hope our conversation is actually spark some of the interesting ideas, and you might have learned something new today. That would be great. What the hell is this? What is? For some reason, I'm seeing some of the. Okay, it's interesting. My downstream key is misbehaving somehow.
Nice. But I just want to quickly say that I dropped the link into the chat, and we're also getting some positive vibes from the viewers. And I just want to say that no, you are the best, because without you, we would not be streaming. It makes no sense to stream when you have no viewers.
I don't see. So if you send the link, looks like YouTube not allowed to send the links. But if you're following this channel, if you're following this my channel, I will share Sergei's video link in the community. So if you go to this channel and like enable some of the messages from this channel,
can do that.
Yeah. There is a it's some of the perks that you can do as 1.7K YouTube subscribers. So I do have some additional bits to promote the show. So I will post it there, folks. So subscribe to the channel. It helps a lot in terms of like promoting this material and promoting this. Apparently, also, Kirill, you missed the previous episode, and we still waiting. Please, we're waiting for chapters. Here's the thing. YouTube was not very good on prioritizing these long videos. So I think they start making effort to change that. So they finally have a very cool support on the chapters in a mobile app. I shared this last week on Twitter. It's incredible, and I think they will start like putting a lot of effort to support this type of things. It helps to YouTube algorithms to find some spots. So that's why chapters are incredibly useful. Not necessarily need to do chapters for this episode, since we're mostly doing talking and blah blah blah, and we're not unloading trucks of potatoes in the potato sacks. This is where I'm trying to translate Russian joke into English.
Even I didn't get it.
No, like it's you know this. I will tell you after because it's a little bit swearing and a little bit profanity. But like
Okay.
essentially the joke is about like speaking about something is not like you're unloading trucks of potato sacks. So
Okay. Yes.
now you
Okay.
understand.
Now I got it.
Now understand,
Oh yes,
guys.
that's smart.
Hit this like button if you also understand this Russian joke, and I hope we will see you next week. Tuesday live streams on Confluent channel, Wednesday live streams in this channel. Sergei Yegorov, Viktor Gamov, and as always, have a nice day.
Bye bye.
Bye.